Okay, I would like you to start working on slide 23 through 28. Should take you about 10 minutes, so please pause the video for 10 minutes and then we'll go over the answers and I'll work through a few with you. So please pause the video for 10 minutes or until students are finished and then we'll go over the answers. Okay, let's see how we did. Slide 23, our answer is 8 plus 2 radical 5. 24, 12 plus radical 15. 25, radical 2 minus 3 radical 6, all over 4. 26, the answer is 2. 27, 10 radical 2 minus 4 radical 5. And 28, negative 49 radical 3, all over 10. So let's go back to slide 23 and start looking at the work for 23 through 28. You can continue working on your homework at this time, or if you need to see a specific number, just fast forward or take a look at the worked out answer keys on your Google Classroom. But I'm going to start with 23 and go through 28. Okay, taking a look at slide 23, I need to distribute radical 2 to 32 and to 10. They're all numbers inside the radicals, so we can simplify. So here we have 232 plus 2 and 10. The reason why I leave them as their numbers is because I'm going to decompose them into their factors. So here I have 2 and 32. Well, what factors do you think of when you think of 32? At this time, you're probably thinking about the perfect square factor of 16. So 2 times 16. Plus 2 and then 10 is 2 and 5. So here I notice I have 2 and 2, and then I have 16. So I can think about this as square root of 4, square root of 16, plus square root of 4, square root of 5. Square root of 4 is 2, square root of 16 is 4, square root of 4 is 2, square root of 5 is square root of 5. 4 times 2 is 8, so I get 8 plus 2 square root 5, and that's completely simplified. These are not like terms, I cannot add them. Taking a look at number 24. Again, I'm going to distribute radical 3 to 4 radical 3 and radical 5. I can only multiply numbers on the inside of the radical by numbers on the inside. So I get 4, and then I'll have 3 times 3 plus 5 times 3. I cannot break down 5 and 3 anymore. They're prime numbers. So I know that this is 4 times square root of 9 plus square root of 15. Square root of 9 is 3, so 4 times 3 plus square root of 15, which I cannot simplify anymore, and 4 times 3 is 12. So this ends up being 12 plus the square root of 15. Excellent. How have you guys been doing so far? Cool. Take a look at slide 25. I have the square root of 3 minus 9 all over 2 radical 6. You guys, we have to rationalize our denominator. So taking a look, there's nothing I can simplify, so I'm just going to multiply my numerator and denominator by the square root of 6. I'm going to put parentheses around my numerator to remember that I'm going to need to distribute the radical 6 to square root of 3 and to 9. So here I'll have 6 times 3 inside the radical, minus 9, and square root of 6 stays inside the radical, all over, and now I'll have 2, and then this is going to be square root of 6 being squared. From here, I know that 6 times 3 is 18, but I can also break this up into 6 as 2 times 3, and then times 3 again, minus 9 times square root of 6, all over 2 times square roots and squares cancel out, 6. This is 3 squared, or I can think about this as the square root of 9 times the square root of 2 minus 9 times the square root of 6 all over 12. Square root of 9 is 3, so this is 3 square root of 2 minus 9 times square root of 6 all over 12. Here's the tricky part. Remember that we need to check the numbers on the inside of the radicals to have any greatest perfect square factors, but I also need to check the numbers on the outside of the radical to see if they have any common factors. So taking a look, what number goes into 3, 9, and 12? 3 does. So I'm going to divide every number just on the outside of the radicals by 3. 3 goes into 3 once, 3 goes into -9, -3 times, and 3 goes into 12 4 times. So that's how we end up with our final answer of square root of 2 minus 3 square root of 6 all over 4. And that is your most simplified answer for 25. Okay, let's look at 26. Taking a look at 26, I have this negative sign that I need to distribute to the 3 and to the square root 48. So remember that this is going to end up being 5 take away 3 plus 2 square root of 12, and I'm going to rewrite the square root of 12 as 4 times 3, minus the square root of 48. Awesome. So let's keep going. What's 5 minus 3? 2. 2 plus 2 square root of 4 times square root of 3, and 48. Do you think of any numbers that go into 48? Well, maybe you think of 4 first. This is 4 times 12. Maybe you thought of 16 first. That would have been lucky. So now we have 2 plus square root of 4 is 2. Then we still have our square root of 3. Minus, because we were subtracting, we distributed our negative. Square root of 4. How can we break up the square root of 12? Well, the square root of 12 is, well, it's 4 times 3. Square root of 4 times 3. So now we have 2 plus, 2 times 2 is 4, so we have 2 square root of 3. Square root of 4 is 2. And now we have another square root of 4 and then a square root of 3. So 2 plus 4 square root 3, no simplifying here, minus, this is 2, square root of 4 is also 2, square root of 3. So 2 plus 4 square root of 3 minus 4 square root of 3. These have the same number underneath the radical, which makes them like terms. If you have 4 square root 3 and you take away 4 square root 3, that makes a big 0. That makes our final awesome answer for slide 26 equal to 2. A lot of really awesome math to come up with such a great answer. Let's move on to slide 27. Slide 27, I need to distribute radical 8 to 5 and to negative square root of 10. So now I'll have 5 square root of 8 minus, and I'm going to leave this as 10 times 8 to break them up into smaller factors. Square root of 8 is a very common radical we run into, and maybe you have it memorized now that it's 2 radical 2, but just in case you don't yet, this is 4 times 2, radical 8, minus, let's break up 10 into 5 times 2, factors of 5 times 2, and break up 8 into its factors of, you guessed it, 2 times 4. So now I can think about this as 5 square root of 4 times square root of 2, minus, I'm going to rewrite this as 2 times 2 is 4, so square root of 4. Oh, there's another square root of 4, square root of 5. Square root of 4 is 2. We still have the square root of 2. Square root of 4 is 2. Square root of 4 is 2. So now I have 10 square root 2 minus 2 times 2 is 4, 4 square root 5. And that's all she wrote. I mean, that's completely simplified. I can't simplify square root 2, I can't simplify square root 5, and I can't subtract these because they're not like terms. Let's move on to 28. Taking a look at 28, remember that the square root of a fraction, the square root radical belongs to the numerator and to the denominator. So that's going to help me simplify this expression a lot easier. So now the square root of 3 is square root of 3. The square root of 100 is 10. And I'm subtracting square root of 75, which I know are factors of 75 are 25 and 3. So now I can think about this as 1/10 of the square root of 3 minus square root of 25 times square root of 3. Well, if I have 1/10 square root of 3, take away 5 square root of 3. Well, 1/10 square root 3 minus 5 square root 3, I just have to think about this as 1/10 minus 5 and then all times the square root of 3. So you can think about this as 1/10 minus 5 and then square root of 3. If I want to subtract, I need a common denominator. So I'd have 1/10 minus 50/10 square root of 3. And from here, we end up with negative 49/10 square root of 3. But like I've told you before, we always want to write these as one complete ratio. So then I'm going to think about square root of 3 over 1. So I'll have negative 49 square root of 3 all over 10. And this would be the most simplified form. There's no more math to be done. Negative 49 square root of 3 all over 10. Awesome. Thanks so much for your hard work today. Let's continue working. Have a wonderful day. Do your best. Be nice to everyone. And I'll see you guys next time.